So we spent a lot of time solving a variety of exponential and logarithmic functions. So what we're going to do is we're going to go to a couple of, more difficult, challenging problems. Right? So our first example is going to be 4 to the x power equals 6 to the x minus 2. And now our goal previously was to try to make the bases the same so that way we could set the exponents equal. And that's just not going to be possible here. And now what makes this more difficult is that when we use our rule and we take the ln of both sides, we're going to have a function on both. So again, my rule from before is the ln of the left is equal to the ln of the right. Okay. And that's going to allow the entire exponent to come out front as a multiplicative factor. And so what I have is I really have x times the ln of 4 on the left. And on the right, I have the quantity of x minus 2 times the ln of 6. So again, it's really important that I put the entire exponent in parentheses. And now what I'm going to need to do is I need to distribute. All right. This left-hand side, I need to distribute the ln of 6 to both of my terms to break up those parentheses. All right. So that's going to look like x times the ln of 6 minus 2 times the ln of 6. And so now that I have distributed, my goal is that I need to be able to move my variable term to combine with another term. So if you notice, I have an x on the left and an x on the right. I need to move this term to the other side so that way I can combine like terms. So I want to be able to move the variable term. And when I move the variable term, because I'm just moving it from one side to the other and it's attached to another term with subtraction, I'm going to undo the operation, which means that on the left-hand side will still be the x times the ln of 4, but now I need to subtract the x times the ln of 6. And that's going to be equal to the negative of 2 ln of 6. Now, in order to combine these like terms, I need to factor. All right? And when you factor, the whole goal is that you have the x, which is the common factor, and then you have what's unlike on the inside. So again, you have to kind of think about what we did when we factored before. If we had something like xy minus xz, they both had an x in common, and so I would factor out the x and leave the two uncommon values inside parentheses. And that's our goal here, but you can consider like the y and the z as my ln of 4 and ln of 6. So that's what I'm going to do is I'm going to factor out my x. All right. Now, there are some things that we can do here in terms of simplifying the ln, but I'm not going to do that right now. I don't want to do too much craziness with rules. I just want to think about everything in the parenthesis is a number. And so now my goal is to divide by that entire parenthesis so that way I can isolate x. So what will happen is x on the left, and I still have all of these operations on the right, and that's going to be divided by my ln of 4 minus my ln of 6. Now again, there are ways that I could have simplified this first and then simplify again, but I don't really want to take too much time doing that because even though this is my exact answer, my calculator is going to do some work for me. Right. So depending on what kind of calculator you're using, this will be easier or not. So what I'm going to do is I'm going to put everything in the numerator in its own set of parentheses. So that way the calculator just knows what's in the numerator. And on mine, when I do that, again, when I start parentheses, because ln has its own parentheses, I need to actually end it with 1. And then when I hit the division bar, then I'm going to do the same thing. I'm going to put the entire denominator in parentheses. So the ln of 4. Make sure you end the parenthesis before you subtract off the ln of 6. And so you need to end the ln then end the denominator. And what we're going to get is, if we round to 4 significant digits, I'm going to get 8.838. It ends in a 0, and I don't necessarily need to put that, but I will. And so this is the value, the approximate value that would make that original true. So you can see that there's a lot more going on when we have variable expressions on both, as both exponents. Right. So let's do that again. Let's kind of practice that one more time. Because sometimes once is just not enough. Right, so 1.32 to the x plus 1 is equal to 4.5 to the x power. So again, I have no idea how to make those the same, so I'm just going to use my rule for ln. Right. And again, showing more work is better than showing less work, so that way if you make a mistake, it's easy to find. Right. So this entire exponent, again, is going to come out front. Make sure you put that in parentheses. Right. Same thing on the right-hand side. The x comes out front. Right. And so again, once I've done that, now my steps are the same. I'm going to distribute, move the variable term, factor, divide, check in my calculator. All right, so I'm going to distribute on this left, and I'm going to get x times the ln of 1.32 plus 1 times that. I can just write the ln. All right. So now I've done my distributing. All right, so now I'm going to move this variable term to the right, all right, because I need to combine that. And so the left will only have the ln of 1.32 is equal to x ln of 4.5 minus my x ln 1.32. All right. So then factor. All right. So I'm going to factor out my x. And now I can divide. All right. So when I divide, I'm dividing by this entire binomial. All right. Now when I put this one into my calculator, I don't need to put parentheses around the numerator because there's only one operation happening here. All right. So we have the ln of 1.32 divided by, I do need to put parentheses around that whole denominator though, just like I did last time. And making sure that you close your parentheses before you hit equals. So again, 4 significant digits is approximately 0.2264. All right, so that's the biggest challenge that you're going to have when working with some of these functions. All right, so just do your best.